Okay, so this is a snap interview regarding geotechnical engineering, right?
Yes, sir.
Okay. So when is your interview, Pooja?
Sir, day after tomorrow for rural technology.
For rural technology. Okay. So before we start, just tell me briefly something about yourself.
So my name is Pooja R. I'm from Neyveli in Tamil Nadu. I have graduated in 2019 with Bachelor of Civil Engineering from Sona College of Technology. My CGPA is 8.92 and my final year project is based on experimental study on shear behavior of slurry infiltrated fibrous concrete.
Just a second. Final BTech project. Can you say that again?
Experimental study on shear behavior
Study.
of
Yes, shear behavior of
slurry infiltrated fibrous concrete.
very infiltrated or fibrous concrete. Okay. So tell me, what have you done in this?
Sir, in this I have made a type of specimen called push-off specimen. That is 2L block, which is like inverted like this. And I have made a notch, and I have given the compressive load, and the determined failure will take place across the shear plane. So we have done this type of specimen to eliminate bending failure and to facilitate pure shear failure. Thereby, we obtain the shear strength of the concrete.
So you have tried to eliminate or reduce bending failure.
Yes, sir.
Okay, all right. So tell me why you want to pursue PhD.
Sir, I'm interested in research. I want to innovate things. That's why I want to pursue PhD.
Okay. So where do you see yourself after completing PhD?
Sir, I want to be R&D scientist in any of the ICAR units such as Indian Institute of Soil
Mhm.
Science or as a teaching faculty in any of the IITs.
Okay. So what is your area of interest for
So my
this
area,
PhD?
this PhD is soil quality management, exactly soil pollution with heavy metals.
Okay. Soil pollution with heavy metals. So have you done any research about
So
heavy metals in soil?
yes, I have gone through one of the paper which is available in the website by Dr. Sudip Mitra from IIT Guwahati. In that,
Mhm.
he has made various indexes to assess the level of pollution of heavy metals, and he just suggested the reformation of framework for dumping of solid waste.
Dumping of solid waste.
Yes.
Okay, go ahead. What else have you done? What else have you researched?
So the basic heavy metals such as arsenic, cadmium, chromium found in the
Hmm.
soil are like very disturbing to the plants. So that when we consume, it disturbs our human health also. It
Hmm.
causes both ecological risk as well as human health risk. To eliminate this is a urgent need of the heart.
Okay, so do you know what is the typical concentration of this heavy metal in soil? Typical concentration.
Typical concentration for every metal it is different. Uh, like there are 12 heavy metals classified
Mhm.
as per the international standards. For every metal that there is, I am not very deep into the specific limit of each one.
Mhm. Okay, so do you know what is the range of let's say arsenic in water or arsenic in soil? What is the range?
So I don't have idea exact range.
Okay, so how do you determine the concentration or this presence of this heavy metal in soil? By which method?
By atomic absorption spectrometry.
Atomic absorption spectrometry. Okay. Have you ever performed experiments on this spectroscopy?
No, sir. This is will be available in very reputed institutes. This is a very costly instrument. I have never
Hmm.
seen this before.
Okay, fine. So yes, okay. So you have done some research at least. So tell me, which is your favorite subject?
So geotechnical engineering.
Okay. Yes, Pooja. So tell me, what is you must have heard three terms. Like first one is soil engineering, next one is soil mechanics, and the third one is geotechnical engineering.
Mm.
Soil engineering, soil mechanics, and geotechnical engineering. My first question is, are these same or are they different?
So they are different. Soil mechanics, in a broad term, includes index property and engineering properties as well.
Mm-hmm.
This geotechnical engineering term not only includes the soil mechanics part, but also includes the foundation engineering.
Mm-hmm.
And this soil engineering, I am hearing this for the first time, actually.
Okay. Okay, no problem. So you told me from where are you? From which place do you belong?
Tamil Nadu, sir.
Tamil Nadu. Okay. So tell me, what kind of soil is present in Tamil Nadu?
In Tamil Nadu, mostly red soil is present near my area.
Hmm. What is the use of red soil?
Red soil. Uh, so I don't know exactly, but here the red soil is like mostly used for cashew cultivation.
Okay, all right. So have you heard of structural water?
Yes, sir. The water which
What
is
is structural
present
water?
in the water which is present inside the pore, which only dissipates after giving an extreme heat of 105 to 110 degrees Celsius, is known as structural water. It is bonded with the structural solid, soil solids actually.
How much temperature did you say?
105 degrees Celsius to 110 degrees Celsius.
This is basically oven drying temperature. Okay, so structural water. Okay, okay. So let's talk about if the structural water is removed, what will happen?
So then the soil just collapses. Structural water should not be removed for any study purposes.
Okay, basically, if like structural water is removed at a typical temperature of more than 500 degrees Celsius. Okay,
Okay, sir.
this temperature can vary from soil to soil, but it is just an average value. Above 500 or 600 degrees Celsius, the structural water is removed. If structural water is removed, then the crystalline structure of soil changes.
Mm.
Okay, the soil changes its shape, its structure, its crystalline structure, everything changes. So, can you give me any example where you have seen the crystalline structure of soil changing?
No, sir.
Have you seen formation of bricks?
Yes, sir.
Can you relate to that now?
Yes, sir.
We use simple, like soft clay soil is there. We burn it in the kiln at approximately 1100, 1200 degrees Celsius. Okay, so at that point, the structural water, any kind of water is removed. The temperature is so high. Any kind of water is removed, so structural water also gets removed. The soil which was soft earlier now comes out as a hard brick.
Okay.
Okay, so that is structural water. My next question is, what is permeability?
So permeability, otherwise known as hydraulic conductivity, is the ability of the soil to allow the passage of fluids through it, especially water.
Okay, okay. So my next question is, what is permeability? A vector or a scalar?
Hmm.
You said permeability is a velocity, right?
Yes, sir.
So
Then it should
velocity
be
is a
vector.
vector quantity, correct. Permeability is a vector quantity. Okay, it actually is a vector quantity. Now see, you have seen like okay. Let me ask you: permeability in horizontal direction is greater, or the permeability in vertical direction?
Hmm. Permeability in uh, like horizontal direction will be greater.
Okay, it is greater. Right? Why it is greater?
So because if permeability in horizontal direction, I took it in the sense that in case of stratified soil,
Mhm.
the stratification is parallel to the flow of water. So the horizontal permeability will be always greater than the vertical permeability.
Okay, correct. Yeah, you are near. Okay, almost 90% of the part you said correctly. Now my question is, suppose that this is the permeability in x direction, okay, in horizontal direction. This is the permeability in vertical direction. Okay, kx and ky. What should be the value of resultant when two vectors are at an angle of 90 degree? What is the resultant?
Resultant will be mm, equivalent permeability of this will be root of kx and ky.
No, I'm just asking you normal. When there is a vector p and a vector q, which have been placed at an angle of 90 degree, what is the resultant of p and q?
When they are placed at right angles. So I'm
Hmm.
not sure about this.
So that is under root p square plus q square.
Ah, parallelogram law.
Hmm. Simple. The
Okay.
resultant is root over p square plus q square. Okay, so my question is, kx is in the horizontal direction, ky is in the vertical direction. If I'm taking the resultant, so resultant should come out to be under root kx square plus ky square.
Mm.
Correct? Am I correct?
Yes,
You getting me?
yes, sir. Yes, sir.
But instead we take root over kx ky.
Mm.
Hmm? So why is that?
So we derived that equivalent permeability by 2D Laplace equation. I can remember that. But why it is not root of k square plus k square? I'm unable. I have never think of that aspect.
Okay, no problem, no problem. You can think of it later on, or you can just Google it, you'll get something. Okay.
Okay, sir.
Okay. So tell me, what is the difference between pressure head and hydraulic head?
So pressure head is just including the pressure term that is P my gamma, whereas hydraulic head is otherwise known as piezometric head. It includes pressure head as well as datum head.
What actually is hydraulic head? How do I visualize hydraulic head? Can you give me an example?
Hydraulic head. Mm, if you
How do we
insert a
visualize?
piezometer, if we insert a piezometer in a sample, soil sample,
Mhm.
uh, the water that rises is pressure head. Uh,
Mhm.
Considering it from the datum level, where we choose the datum, uh, that the summation of both pressure head and datum head gives us the hydraulic head.
Okay, but datum can be different, na?
Yes, sir.
Datum is not a standard value. Pressure head, I got your point. Pressure head, what you are
Mm,
trying to say is correct. But when you say that you add pressure head and datum head, it gives us hydraulic head. But if I take datum is different, you take datum different, maybe we'll get different values of hydraulic head.
no, sir. We don't get different values of hydraulic head even if we choose different datums.
Why?
Because as per the datum head, our pressure head changes.
As per datum head, pressure head changes. How's that? Okay. Okay. So when we write that, what is Darcy's law?
Darcy's law is V equal to Ki,
Okay, V equal to Ki. All right. What is I?
hydraulic gradient.
Hydraulic gradient. This is equal to,
Head loss per unit length.
what is this head loss?
Head loss is the head which is causing the flow, or it is the difference between upstream level and the downstream level.
Basically, this head loss, what you are writing now, it is actually your hydraulic head.
Mm. Okay, sir.
Okay. Just try and observe this thing again.
Yes, sir. Mm.
Okay, you can make a note of this, and after we are done, you can just go and watch all your notes, and you will get this thing. What
Mm.
H head loss you are writing, it is nothing but your hydraulic head only.
Yes, sir.
Okay, what is shear strength?
Mm, shear strength is a property of the soil
Mhm.
uh, by which it has a proper bonding. Soil usually fails in shear.
Okay, so have you heard of direct shear test?
Yes, sir.
So can you explain me what is direct shear test?
Sir, in direct shear stress, we keep the soil in and we slide it over one another. Like bottom part of the box will be sliding in one direction, and the other part will be sliding in other direction. This
Mhm.
sliding movement is recorded by a proving ring,
Mhm.
and the moment at which the boxes slide over one another and is recorded as the breaking
Okay,
point. Or,
fine, fine. So you know the process. So let me give you a situation. Okay, this is a practical situation which you might face in the laboratory or something. Okay, so just try and understand. Okay, consider this as your shear box. Okay, this calci over here, this is my shear box. Okay, and let me just give you a big screen. Okay, you can see this is my shear box. First of all, I'm applying some normal load from here and from here. Okay, a normal load is applied from upside and from downside, from downward. And you know that load we are applying using machines. Human body cannot apply the load, correct? We are applying load from machine. Now what is happening? My load is still over here. Okay, I have applied some vertical load. Now I'm applying some horizontal load, some shear force. Okay,
mm, mm,
to slide it off. I'm applying shear force, shear force. The body has not collapsed. It has not failed in shear. And suddenly electricity goes off.
mm,
Okay, suddenly what happens? Electricity goes off. The system remains as it is.
mm.
Okay, now tell me how will be the graph of direct stress, direct shear test graph? How will be that graph?
Sir, I have no idea.
Okay, let me help you. Uh, do you remember any assumptions involved in direct shear test?
Yes, sir, the soil is homogeneous and isotropic.
Other
The
than that?
loading plane,
Mhm.
I'm unable to recall it.
Okay, so there it says that uh, the failure conditions are only known at the time of failure.
Mm,
Okay, when the soil has failed, then only you get the value of stress. If the soil has not failed, you'll not get the value of stress. Okay,
mm.
so your graph will be nothing. It will be zero. There will be no graph
Okay.
because the soil is actually not failed.
Mm,
Okay, so basically, this question was asked itself in an MTech interview. So I've given you this situation. Okay, it was
okay,
like
sir.
long back ago, 3 or 4, 5 years back. This question was asked.
Mm,
Okay, so I guess Pooja, you are good. Okay, just do some more research on your BTech
mm,
project. Okay,
mm.
uh, they will not ask you much questions from your BTech project because your this topic is entirely different from what you are going for intern. Okay, so they
Mm,
might not be much interested in your BTech project. Okay, but if you have done some research, okay, like you
mm.
said, arsenic, cadmium, chromium, and all, so just do some more research. I'll say
Okay, sir.
just see some papers of Dr. Abbas. Okay,
Mm.
he is a professor in IIT Kanpur.
Okay, sir.
Okay, he has been doing work on this contamination of water using from this heavy metals. He has done a
Okay,
lot
sir.
of research in this. He specializes in this field only. Okay, so
Okay,
do
sir.
some more research. Else your technical part is good, not a problem.
Okay.
Still, you can do some more stuff. Okay, you can study some more, and then just let me know whenever you are prepared. We can have one more snap, or let's say a mock final.
Okay, sir.
Okay, okay,
Yeah. Thank
all
you.
right.